We're going to start this puppy up. Clear, prop.
And welcome back to Tip of the Week. Some of you may be really into ultralights. And for those of you, some of you probably are familiar with the Rotax 582 two-cycle engine. There's quite a few out there. Rotax still produces that engine today. Well, this week we have a series on how to examine and tear apart that engine step by step, and this is going to be demonstrated by an expert engine rebuilder, Alan Lehman, and he took the time to create a video for us of what he looks for when he takes these engines apart and then shows you what it is that has gone wrong or what needs replacing. Let's get started with our first installment.
We've got a 582-99 version that's come in for maintenance. It's a 5-year-old engine. You might ask how I know that. What do you see inside there? 00 and a bunch of dots. This engine was made, and I'm going to look at the picture there, the 9th month of 00. See, it looks like a clock. It looks like a clock, and the dots show what month. And it goes around to the 9th month, 8th or 9th month, okay, of 2000. Okay, so we know this is approximately a 5-year-old engine. It is said to have 60 hours on it. With 60 hours but 5 years, I know we're going to find some leaky seals. Your seals will start leaking at approximately 3.5 to 4 years old. Not of use, but of age, since it was manufactured. This is a C gearbox. It is designed to take higher torsional loads, which means it can swing a larger prop and it can swing a heavier prop. It also has the 2 drains, or the 2 fill marks. The engine in this configuration fills to this hole. If it were to be flipped over, so it's hanging down, you would use this hole. It would be over here at the bottom. Okay? And again, if you flip it over, you have to reverse the vent and the drain. That's what that bushing's in there for. Okay? It's to cushion the bottom of the radiator, and the top of the radiator fits here, and this is for the dual radiator system, one on each side. If you notice, there's a big opening here. That should never be plugged. See that rubber? It looks like an inner tube in there. The steel piece is the flywheel. That is, it's called a donut. We call it a donut. It's actually a torsional. It flexes sideways if the prop were to hit some resistance. It gives it a little bit of cushion, so all of the vibrations coming through the engine don't make it to the prop. It acts as a cushion between there. A couple things we're going to look at here before we start any dismantling is, and these are all wear indicators and things you ought to be looking for while your engine is still in service. I don't know if you can tell, but it looks dirty or oily right around this area here. Can you see that? Okay. This is an indication that the rear seal's leaking, because it's going to, behind that flywheel, it's going to fling that oil around there as it comes out of the rear seal. This is not sealed into the gearbox. There's this chamber in here that's empty. So any oil that leaks out of the engine goes into this cavity, and if it happens while the engine's running, it flies off the flywheel, or even when the engine's stopped and it drips on the flywheel and then you start it. It flings it off and you'll start seeing it around this surface. Same way if you were to have a head gasket leak, it would show up around this gasket. I don't really see any marks up around here, but if the head gasket were to be leaking, that's where it would leak at. 582s come with 6 exhaust bolts, but you should always use your exhaust bolts in pairs. With the manifold on, you cannot get the bolts in these two because the manifold's coming together and you have no clearance to get the bolt in there. In a case like that, we put a stud in it with a nut and draw it on with the nut. Then we can use all 4. If you're going to use less than 4, only use 2. Only use 2 and use them in opposite corners. This guy used the 3 right in these 3 holes, and you see where it started to leak out the 4th hole. This one had a better seal evidently, or it could have had a flatter surface on the manifold. A slight warp in the manifold will cause it to leak. These must be aligned perfectly before you tighten the cylinders down, because if you have them angled in or angled out, they won't mate with the exhaust manifold properly. And that's what this tool right here is for. You simply jig it on there. I've got nuts that are dedicated to it. I mount it on there. When the cylinder's loose, you torque the cylinder down, and those are straight across. They have a flat face. Couple other things you want to look for is if you see any kind of the same dark coloring between the crank halves. Okay, and if you start seeing a dark spot, this is all sealed up here, so the front seal doesn't readily leak, you know, to where you can see it. However, right under here is a big hole. And if you look, right up there is your stator plate. And if this engine is leaking, if it's mounted plugs up and it's leaking, the oil will leak right down here and it'll drain out. I don't feel any wet oil around that hole, so I'm going to say the front seal's not leaking. That's a guess right now, but that's what I say. I believe we're going to find the rear seal is leaking now. Okay, the next thing we're going to go through is how to remove a C-box. C-box quite a bit different than a B in appearance and also in functionality. First thing, it has internal bolts in it also. In fact, more than the B-box does. The only external bolts it has are these 2 down here. And the C and the E box use all 8 bolts. It doesn't just use 6, it uses all 8. First thing we're going to do is simply break and remove all these screws around the gearbox face. And this is our last one. You want to kind of keep your hand against there just to make sure that the face doesn't fall off in the floor. Although it shouldn't. It usually takes a little bit more effort. And we could get some oil drippage, although I did leave this drain for about 4 or 5 days. If you notice, there's a little place here for you to hammer on the back. This needs to come off fairly well straight, because this shaft, if you can see it, is actually going to pull out that seal. It's going to come off with this faceplate. Starting to come loose now. There we go. And that was the back of the shaft that was going through that hole. Yeah, what we had drip was just this little bit. If you notice, the oil is very clean. It still looks like brand new oil, as opposed to the A and B box that comes out pretty black looking. And we discussed that. That is because anything that blows out of the back of the engine goes into an A or a B box. With this open compartment here, that can't happen with the C and the E. It's actually an air chamber in there. And you'll understand it more as we go further into the teardown. Okay. We're going to break them all loose. That's 2 in here, 2 over there. The lower ones are external, the upper ones are internal. Normally this is the correct procedure for disassembling, as you want to pull your gearbox, electric starter, anything that's on the crankshaft on either end of the engine. You want to remove them first. You'll see why as we get further into this gearbox. Okay, we've removed all 8 of the bolts. In fact, I keep them in a tray right here. But the gearbox still won't come off. There's something else has to be done. What we have to do now is separate the drive gear from the donut, the rubber donut that's in here. And if you remember back when we were talking about the 503, we discussed the piston ports. If you notice, your pulse port, I'm sorry. And if you notice, the pulse port in this 582 is in the magneto end of the engine. Can you see it there? Okay. Somebody left a clamp on it. We'll take that off. I'm glad to see that they used a metal clamp there, because the engine does get hot and you shouldn't use the plastic clamps there. But anyway, with that being clear on the other end of the engine, we don't have any way to, and again, if we put a pin in that, we're going to twist on all these joints that are pressed together. So the correct way to do this is to, first of all, Get your piston up to top dead center. Figure out which way we're going to want to turn this thing, which we're going to turn it counterclockwise, so we want to go past top dead center, starting down the other side. I'm looking in the exhaust port to see where the piston is, because if the piston is too low, you can actually put the rope down a piston port, and then when you go to put pressure on this, it will cut, the ring will cut it, and then you probably bent the ring, and so you put it up near top dead center. You run the rope down in there, and all we're doing is feeding it in the spark plug hole with the piston very close to top dead center. And we've determined that by looking in the exhaust port. We moved it past top dead center so that when we back up on this, which is the way we're going to turn the screw that's inside here, it will lock, the piston will come up and it'll lock it. Let's see how we're doing here. Okay, yep, it just locked. It's a 6mm Allen screw in there. Break it loose. You want to make sure you keep good tools around. If your tools start wearing out, wearing the ends off, because if you strip that out in there, there's just no way to get it off without cutting the gear off, and then you might as well throw this gearbox away. Okay. And that's all that's in there, just that screw. I personally leave it in there. And one thing I did want to show you here that I didn't. There is a gap right there, if you can see it. There's a little gap that allows anything that's leaking out the rear seal to drain down and come out of here. And you notice how black this is. What, in all probabilities, that is coming out of the back of the engine, because we saw how clean the gear oil was. It's not gear oil, or it'd be the same honey color that gear oil was in the gearbox. It's black, which usually comes out of the rear seal. So if you're real greasy under this section, odds are your rear seal's leaking. Lay it back down here. Get a rubber hammer again. Now this is put on the back of the engine with an anti-rotation compound that fills up the tiny little gaps to help keep it from rotating. Okay, now it just slides straight off. I want to turn it down this way so that Allen screw in here doesn't go anywhere. And we're going to put this on the cart. Even though this gearbox this gasket didn't tear, you should always replace the gasket. Once they get oil soaked, they tend to seep. This one will get a new gasket. And now you see what we have as far as, this is the flywheel to the gearbox. It's a part of the gearbox. This is the rubber donut, which I don't know if there's a good way to show you here, but we'll try. Whoop. There we go. See it flex a little? If something were to stop the propeller, or if there was too much vibration through the engine, that will absorb it, so it's not transferred to the propeller if it's from the engine. If it's from the propeller, it won't get transferred back into the engine and maybe twist the crankcase out of phase. Okay? And at this point, these are not simply Allen screws. They take a special wrench. It is an Allen wrench, but it has these protrusions on the end of it. That keeps it lined up straight when you put torque on it. It doesn't twist the thing sideways, because that works as a pilot hole. See there, if you look inside there, there's a pilot hole in there. Here's a standard one, just without that pin on the end. And if you notice, see how much this can wobble? So this is made with that tip where it won't wobble sideways like that other one will. Okay. That's one loose. And if you notice, these washers back here have two flat sides. That is so when you tighten them, wrong size, but when you tighten them, you hold that washer so that it doesn't do this. If I didn't hold that washer, well, I'm not going to do it right now, but if I didn't hold that washer when I was tightening it, it would start to twist. That rubber has a metal sleeve inside of it to keep it from compressing. And as you tighten it, it will twist the rubber end, putting more load on it. So you hold a wrench across there just to keep that from turning when you put your final torque on. It doesn't allow the rubber to twist, which will make it wear out quicker. Okay, one thing you need to know about this rubber donut is if you ever take it off, that screw won't screw back into that hole. It's not starting, because the donut holes are slightly larger than the holes in the flywheel. And to line that back up is not a complicated thing. You simply use a circle clamp, fit it around that donut, near the center, and I'm just showing you this for effect, but you loosen it up, you fit it around the donut, you start one, you know, you can start any one of them that you want to, and then you tighten up on the clamp until the other one starts finger tight. Then you go to the last one and you adjust it as necessary, looking in the hole if you need to see how far off you are. And once you get it clamped to the right thing and get these tightened, and again hold the washer before you tighten it, then you just take the clamp off and it's fine. Okay, we paused the film there so you just didn't see us unscrewing the screws. We're going back now because we're at the last one, and all you do here is take it off, and you notice that there is Loctite on those. Most bolts in this engine will use some type of Loctite. There's a few that don't. It's easier to remember the ones that don't rather than all of them that do. Is this rear seal leaking? Remember, we saw evidence of it Does that seal look like it's leaking? See any signs of that seal leaking down there? The rear seal is definitely leaking. We're probably going to find a minor amount of leakage on the front seal. Okay, at this point, again, our rope's still in here. You can't get this nut off without that rope in there. This nut is an American. This is the only American nut you're going to find on the whole engine. It's a 3/4 inch. So all we're going to do here is try to break it loose. That one's on there with, if I'm not mistaken, with 44 pounds of pressure. 44 pounds of pressure, and it does use 242 Loctite, which is the blue automotive type. And it, like the A and B gearbox, is on a tapered, the crankshaft is tapered there. It's a press fit onto there, onto that taper. And I'm turning it here because we're getting ready to pull the gearbox. I mean the flywheel. Now, if a person wanted to, they could probably use a 2 or 3 jaw puller to pull this gear. If you break it, not the gear, the flywheel. However, you're pulling on these 3 lugs right here. If you were to break it, these are relatively expensive parts, even though it looks like it shouldn't be. And all I'm going to do here is we're going to mount this onto here with the bolts that came out of here. But before we do that, you see where the end of that bolt turns on the end of the crankshaft? We've got a button that protects the end of the crankshaft there. And we simply slide that in and then mount that on it and push on the button, so we don't accidentally go inside the threads and ruin them or ruin the end of your crankshaft. Okay, let me put the screw in, line it up with the hole. Now we're going to be turning this nut in the opposite direction. See, it's going clockwise, which means this rope is keeping the engine from turning that way, but it will turn the other way. So we want to pull that out of there, take the piston down all the way back up, back it up just a little bit. Same thing, we're just going to reinstall the rope into it. Because we're going to turn this the opposite direction, the piston has to be coming up on the other side for it to work properly. And now when this flywheel comes loose, it may pop out on the floor. Yep, popped loose but didn't fall out. And she's off. Take your button off so you don't lose it. This surface, this tapered surface on the end of the crankshaft and the inside surface here should be cleaned with carburetor cleaner, some kind of a solvent that will take any oil off of it. Then you put a light amount of blue Loctite 242 and spread it inside here. Don't spread it on the end of the crank, just spread it inside here. And that's the same for all the redrives, at least all the redrives that are steel. Okay, at this point, we're going to take this one had an electric starter on it. So we're going to go the standard Rotax electric starter. We're going to go ahead and take this off along with the vibration dampener that's behind it. I don't care how good you think you've drained these engines, unless you invert it and get all the water to come out this point here on top of the engine, you will never get all the water out. There is two compartments in the cylinder that don't vent to the bottom. And I think it's on this side here, because that side has a water jacket. Yep. And they actually just bottom out down there. Well, that water is going to stay there. When you remove the head and the cylinder and go to pull it off, that water is going to drain down into your crankcase, that antifreeze. And then while you're sitting here working on the engine, whatever, it's building rust. So before we drain this engine, or before we tear the engine down, we're going to make sure we get all that out. And the reason I wanted you to focus down here was just to show you, I just went to tilt it back and water started coming out. Antifreeze. Okay, right here gives you a real good shot. This plate back here, that one's half covering the hole, that one's completely covering it. That is your rotary valve plate. So much of it is missing, and that is during the time that open area opens over the hole, that is when that piston breathes in, or that cylinder. And see how it rotates around? See, this one's drawing in right now. And now the piston's starting down and it's sealed it off. If something tries to blow back, it will seal off because that has oil on it. And over here, now this one's opening. It's drawing air. Boom. It's closed. The piston's starting to come down, and that's keeping the blow by from blowing back, or attempting to. Thought I'd show you that. That is all part of this cross shaft system. And again, on this side, your water pump, which is just rotating on the other end of the shaft. We're going to go ahead and drain this center section because we've got to get all this oil out of here. All this oil does is drain down this tube. It enters down here. The two gears, the crankshaft and the cross shaft, are both on beveled gears, which cause the oil to move in one direction, such as an oil pump. Okay, and it blows it. This is a completely filled system, so the circulation starts to push the oil up here. And if you can see, there's an arrow. This arrow is going up, this arrow is going down. That is the direction of flow. And the gears are causing it to flow. Okay. One thing, this should always be kept full. And if you can notice right there, there is a line, and it says oil, there's an arrow, and then a line. It says oil. Yep. There's an arrow and then a line under it. That's where the oil should stay. Now, let's talk for a minute. Can this, if he filled this up to the proper line, why is there more oil in it now, and that is the oil level, then why is it above the line? There's, well, basically one possibility of what could have happened is if your water pump, especially on the Silverhead, the 90 versions, they didn't have the ceramic water pump seal, and usually because the pressure in the radiator is higher, this has no pressure, this is zero pressure. Normally when you did have a water pump seal issue, the water would come into the center section, thereby making this level go up. As the antifreeze mixed with the oil starts to turn a phosphorescent color. It's a very bright green, almost a day-glow color. When, you know, if you see anything like that, it's definitely time to drain these and figure out if there's water, antifreeze, whatever in there. And again, it should be about every 2-year maintenance item, if not more often. What we've got to do first here is we've got to drain the oil level down below the tops of the tube. Then we're going to remove this tube here, and we're going to simply drain it down into a can, and that will drain all the oil from the bottom of the case. I removed the clamp there so that when I pulled it down, you wouldn't have it catching this much oil. One thing, if you don't know it, the white ties are not UV resistant. The black ties are. So whenever possible, use black wire ties. They are more UV resistant and will last a little bit longer. I'm going to take the cap off, and we're going to start the unfilling process. We want to go ahead and look at our oil to see if it's foaming. These bottles get a little bit dirty, but you want to look, it'll start looking milky if it's mixing with water or antifreeze. It's all a pretty consistent color, which is that dark color, and it the center section just uses the same engine oil that you use to premix your gas or to inject your gas. This is a water-cooled engine, isn't it? So why would we want to use an air-cooled oil? I'll tell you why. Outboard motors and jet skis, which is what marine grade oil or marine grade two-stroke oil is all about, they don't have a radiator system. They draw their water from the lake or river or whatever body of water that they're in, and they spit the warm water after it goes through the engine right back into that same body of water. So they run at cooler internal temperatures than a radiated system. Air-cooled is recommended for the water-cooled engines, in the two-strokes anyway. And drain it. Now, it doesn't look green anymore. It definitely has a brownish look.